Welcome to another episode of Explained by AI.
Hey there.
So if you're a junior DataBricks engineer, chances are you're working with Delta Lake tables quite a bit.
Absolutely, yeah. They're fundamental.
And two features you'll definitely bump into are AutoOptimize and AutoCompaction.
Right. Those table properties.
We want to really dig into what they are, when to switch them on, crucially when not to, and maybe why just enabling everything isn't always the smartest move.
Yeah, that can get expensive if you're not careful. Think of this as a practical guide, moving beyond just the defaults.
Okay, so let's start with the basics. What exactly are these two features tackling?
Well, the core problem is small files. It's a classic data lake headache, really.
Right. Lots of tiny files everywhere.
Exactly. Every time you write data to a Delta table, you generate files. If you do lots of small writes, you end up with tons of small files.
And that's bad because
It slows down your queries
Yeah.
a lot. The system has to open and read metadata for every single one of those files. Plus, it costs more in storage reads and compute, and it just doesn't scale well.
Okay, makes sense. So how do AutoOptimize and AutoCompaction help?
So AutoOptimize tries to fix this during the write process itself. As the data is being written, it attempts to merge small files together into bigger, more optimally sized ones right away.
So it's proactive during the write.
Precisely. Then there's AutoCompaction. This one works differently. It runs in the background after the data has already been written.
Like a cleanup crew.
Kind of, yeah. It looks for partitions or tables with small files that might still exist. Maybe AutoOptimize didn't catch everything, or maybe it was turned off and it combines them later on.
So AutoOptimize during the write, AutoCompaction after. That seems like a key difference.
It really is. Understanding that timing helps decide when each one is appropriate.
Okay, so given that difference, when should you actually, flip the switch and enable these? Let's start with AutoOptimize.
AutoOptimize shines when you have frequent small data writes. Think streaming data coming in constantly, or maybe microbatches running every hour, or even more often.
Because otherwise you just accumulate thousands of tiny files really quickly.
Exactly. In those cases, AutoOptimize prevents that buildup proactively. It stops the problem before it gets out of hand.
Right. And AutoCompaction.
AutoCompaction is generally a good idea to have enabled for most serious production environments. It runs in the background, so it doesn't really hurt your write performance.
So it's less intrusive than AutoOptimize.
Yeah, you could say that.
Yeah.
And it helps keep things tidy, maintaining efficient file sizes, even if you have, say, occasional larger data loads mixed in with smaller ones. It's good housekeeping.
Okay, so generally enable AutoCompaction. AutoOptimize for streams and frequent small batches. That covers when to turn them on. What about when to turn AutoOptimize off? Seems like you wouldn't always want it.
That's right. The big one is large bulk data loads. We're talking loading hundreds of gigabytes, maybe millions or even billions of rows, all in one go.
Why turn it off then? Wouldn't merging files still be good?
Well, when you're writing that much data, having AutoOptimize also try to merge files concurrently can actually slow down the whole write job quite significantly.
Oh, right. The overhead of optimizing outweighs the benefit during that massive write.
Exactly. It can extend the job time, and sometimes it might not even do a great job creating perfectly sized files anyway, just because of the sheer volume and speed.
So what's the alternative for those big loads?
It's often much more efficient to just let the write finish as quickly as possible with AutoOptimize disabled. Then afterwards, maybe during off-peak hours, you run an explicit optimize command on the table.
Manually trigger the compaction.
Right. You get the fast write, and then you clean up deliberately. And sometimes, after a big load like that, you might also want to run optimize with Zorter by on your key query columns for even better read performance later.
Makes sense. Any other times to disable AutoOptimize?
Yeah, another case is if absolute lowest latency for the data ingestion itself is your top priority. If you need that transaction to commit the instant the write finishes, the extra milliseconds AutoOptimize might add could be unacceptable.
So for like real-time bidding or something super time sensitive.
Potentially, yeah. If every millisecond counts on the commit, disabling AutoOptimize can shave a little time off.
Okay, let's tackle a common scenario I've seen. You have a daily batch job, right? But the size varies wildly. One day it's tiny, just a few megabytes. The next day, maybe end-of-month processing, it's huge, hundreds of gigs.
Ah, yes, the variable batch size problem. That's
But
a classic.
How do you handle optimization there? You can't just set it and forget it, can you?
No, probably not optimally. The best approach there is usually dynamic. You need to adapt, meaning you check the size before you write, you have some logic in your job, maybe in PySpark or Scala.
Okay, so you measure the data frame somehow.
Right. You could count the records, or maybe estimate the size in memory or bytes. You define a threshold, what counts as small versus large for your workload. This threshold is key, and you might need to tune it. If the data frame is below your threshold, small, keep AutoOptimize enabled, or enable it just for that write using table properties. Let it handle the small files automatically.
And if it's large, above the threshold.
Then you programmatically disable AutoOptimize before you execute the write command. You set the Spark session configuration or the table property spark.databricks.delta.autooptimize.enable to false.
Just for that specific write operation.
Correct. Let the big write finish quickly without the optimization overhead.
But then you've potentially written a lot of data without optimization.
Right. So the second part of the dynamic approach is, after that large write completes, your job then triggers a manual optimize command for that table.
Ah, so it's conditional. Check size, set AutoOptimize accordingly, and if it was large and AutoOptimize was off, run optimize manually afterwards.
Exactly. It gives you the best of both worlds. Automatic handling for the frequent small, medium batches, and efficient handling for the occasional massive ones.
That sounds like a solid strategy. A bit more code, but probably worth it for performance and cost.
It often is, yeah, especially in production pipelines where consistency and efficiency matter.
Okay, so let's try and wrap this up. If you had to give a junior engineer the key takeaways, the sort of rules of thumb for using these effectively, what would they be?
All right, rule 1. For streaming data, or those frequent small microbatches, definitely enable both AutoOptimize and AutoCompaction. Let them work together.
Okay, streams, small batches, both on.
Rule 2. For those big infrequent bulk loads, or if write latency is absolutely paramount, disable AutoOptimize before the write. Yeah. But generally keep AutoCompaction enabled to handle background cleanup later, or plan for a manual optimize.
Big loads. AutoOptimize, AutoCompaction probably still on, maybe manual optimize needed?
Right. Rule 3. If cost saving is really your #1 driver above all else, you might consider enabling only AutoCompaction as it runs, potentially on cheaper background compute and avoids any overhead during the write. But that's a trade-off.
A cost-centric approach, maybe just AutoCompaction.
Yeah. And the most important principle overarching all of this, don't just blindly enable everything. Understand your workload.
Know your data patterns, right? The size, the frequency.
Precisely. Analyze your writes. Is it streaming? Big batches, variable? Make an informed decision based on that data. Just turning knobs without understanding why? Well, that's not really engineering, is it? It's guessing.
Yeah, it comes back to understanding what's actually happening under the hood with your data pipelines. Don't just accept the defaults without thinking.
Couldn't have said it better myself. Getting these settings right based on your specific needs is key to building efficient, performant, and cost-effective pipelines on DataBricks. It's a detail that makes a real difference.
Absolutely. Well, that wraps up our deep dive into AutoOptimize and AutoCompaction for Delta Lake in DataBricks. Hopefully that gives a much clearer picture.
Hope it helps.
Do you have any topic that you would like to have explained? Drop it in the comments.